All right, guys, so as I was saying, it is meaningless or to divide by 0. So in math, we don't have a definition for it. So we say it is undefined. All right, now whereas dividing by 0 is undefined, we can divide 0 by a number and there's no problem. So for instance, I was saying that if you have 0 divided by 20, why is this not a problem? Why is this not a problem to divide 0 by 20? What is the answer supposed to be? Anybody?
0, sir.
All right, the answer is supposed to be 0. And we said that is not a problem. Now, can somebody explain to me why you think this is really not a problem? Why, when you divide by 0, it's a problem, but if you divide 0 by a number, it is not. Go ahead, Miss Cummings.
So because you're dividing by something?
Well, yes, you're dividing by something, but what are you dividing by something? Now you're dividing 0 by something. What does that really mean? What it means to divide 0 by something? Or suppose you say you're dividing 0 by 20. What does that really mean?
I mean, that means you're trying to take 20 parts out of 0.
You're getting 20 parts out of 0. And can we do that?
No, sir.
Out of 0.
No, sir.
It might seem kind of a little strange, but yes, we can get 20 parts of nothing out of nothing, right? Because if I have a whole bag of nothing, right? I could part that bag into different spaces of 20 space of nothing, right? So within that, so you create some compartment of nothing within the nothingness of the bag. So in other words, you make different parts of the bag where you have each of those parts have nothing. So you have 20 nothings within the whole bag of nothing, which give you nothing. So there's nothing wrong with that. Does that make any sense to you guys? So in other words, you're dividing a space that is empty into 20 spaces that are empty. And there is nothing wrong with that. Anybody is in agreement with what I'm saying? Or anybody gets the idea why we can divide by 0? Now, if you don't want to see it in that way, then we probably can use the multiplicative property of 0. Now, 20 divided by 0 would be the same as 0 multiplied by what?
20, sir.
Not 20. 0 times what give you 20 over 0? 0 times what give you 20 over 0? What am I multiplying 0 times to get 20 over 0? Zero times 1 over 20 is the same as 20 over 0. You agree?
Yes.
Do you agree, guys? Miss Green? If you're multiplying the numerator, remember now, if you can convert 0 into a what? A fraction. Or you can put it over 1, right? Because 0 is a whole number. So if you say 0 times 1 in the numerator, you get back 0. 1 times 20 in the denominator, you get back 20. So this is the same as saying 0 times 1 over 20. Do you agree, guys?
Yes, sir.
1 over 20. And if we go back to the multiplicative property, we say 0 times a number give you what?
It gives a 0.
0, because 0 times 1 give you 0. 0 times 2 give you 0. 0 times 3 give you 0. So 0 times 120 will also give you 0, which is the same as 0 divided by 20. Do you agree, guys? Are you seeing what I'm saying? I know
Yes, sir.
some of these ideas are a little abstract, and so I'm trying to break it down as real as I can make it based on what I'm doing. All right? So the same idea where you can multiply 1 over 20 by 0 means that you can divide 0 by 20, and it is okay because you're really dividing nothing into pockets of nothing. So you divide nothing into 20 pockets of nothing. When you add up all of those 20 pockets of nothing, each of them would be nothing. So 20 times 0 would give you about 0. Is that clear now? Is it clear now? Are clear now, Miss Green?
Yes, sir.
All right. Miss Scott, is it clear? Miss Cummins, is it clear?
Yes, sir.
Miss Scott, I'm not hearing you. Are you clear on this one? Mr. Arjano, are you in agreement with us?
Yes, sir.
Okay. All right. Now, why I'm trying to break down these concepts to you guys is so that you don't have any doubts about what you're doing. So clearly, if you see something divided by 0, what should come to your mind? What would be?
It's meaningless, sir.
Go ahead, Miss Cummins.
It's meaningless.
It is meaningless. So if you get that as a maths question, you're either going to put down it is meaningless, or you're going to put down it is equal to undefined. Don't undefined really mean that it doesn't have a definition. Then, and it's the same thing as not having any meaning. All right? Things that we can define have meaning, but things that we can't define don't have any meaning. All right, moving along then, guys. So here now we have sequence of arithmetical operation. Now, we would refer to the operations that we'd have seen before, operations of arithmetic, because we use them quite often when we're doing arithmetic. Now, in addition to these 5 operations, I'm going to look at the order in which we do them. Now, first, in general, you would work out what is in brackets first. Now the division and the multiplication must be done before you do addition and subtraction. So that's the order in which we carry out these sequence of operation. Now we have this, what I would call mnemonics, to help you to remember the order in which we calculate these operations. Now, if you notice that I've added, and in this operation, we have added E for exponent. Another name for exponent would be what? Guys, what's another name for exponent? Power. And what do we, what power really means in maths? So suppose I have 3 to the second power. What does that mean?
So it
3
means
times
that
3 there.
All right, Miss Cummins, you were saying something?
I was saying that you're multiplying 3 by 12.
Okay. Does everyone agree with that? Raise your hand. I know it might be trivial if I answer this question. It might sound trivial, but I can tell you what I see some students do sometimes. Sometimes you will see students multiplying 3 times 2 to give you 6. But that's not what you're supposed to be doing. That would be very wrong. What you should be doing, 3 squared, the power here only tells you how many times you have to multiply the base with itself right? Or how many 3s that you have to have when you're multiplying it by itself. So if the power is 2, it means that you have to have 2 3s. So you would have 3 times 3. If you have 3 to the 4th power, the power will tell you how many of the base you should have. The base here would be the 3. How many of it you should have when you're multiplying it by itself? So you should have 4. So you should have 3 times 3 times 3 times 3. And so when you count the amount of 3s, you should get the same amount as what the power is saying. So you have 1, 2, 3, 4. So the power should be 4. Is that clear to everyone? Is that crystal clear? Raise your hand. Raise your hand if you're all comfortable with what we mean by power. All right. Now I see persons are putting up their hands in a very reluctant way, as if they're not sure of what they're saying. But we'll find out as we move along. Now we have, how many operations we have here in all now? We have brackets, exponents, division, multiplication, addition, and subtraction. Now, oftentimes you may get a question that not just have only one of these operations, but maybe a combination of the operations. And if you get a combination of the operation in one question, for instance, you may have 3 times 2 plus 12 divided by 4 square No, let me not use 4 square. Let me use instead 2 square plus 3 times bracket 5 minus 2. And you're to do that calculation. Now, so this is an example of where you may have a combination of the operations together in one question. And when it is like this, in order to get the correct answer, you have to work them in a particular order. And if you notice on the right-hand side where I list bracket, exponent, division, multiplication, addition, and subtraction, if you notice that the first letters are highlighted in green so that it can spell this word that we call bedmass. Now we use the word bedmass to help us to remember the order in which we should carry out these operations. So if you remember that word every time you're working out these problems, bedmass, then you will work the various operations based on the order of these letters in bedmass. Now, some books may have BOMDAS, which is really the same thing as bedmass. It kind of just rearranged the letters in a different way. So bedmass and BOMDAS would give it the same order in a respect. So based on this, what is the order now of the operation, students? What you work out first, what you work out next, and what you work out next? Can somebody tell me what you work out first?
So we work the bracket first.
Right. So to work out what is in the brackets, what you will get for this?
3.
All right. So we would, all right, let me just, so we would work the bracket first. So we, inside the bracket, we say 5 minus 2, we get 3. Now, what is inside the bracket? Remember, there's an invisible multiplication sign here.
Yes,
Means
sir.
that you have to still put back the multiplication sign between these two numbers. All right. Now, after you work the brackets, what else you would work next?
The power.
So you work
Exponent.
bracket, then you work power. Now, this is the one with the power. So we would write back the 12 divided by, when we work out the power of 2 square, what we get?
4.
4. So that means that we would have 4 right here. And then now, could go ahead and multiply what we have over here. 3 times 2 give you
6.
Now, in the same respect, what would we do next?
The division, sir.
We can do this division. Because remember we said division and multiplication can be done at the same time.
Yes, sir.
So these we can do at the same time. So now we would have 6 plus 12 divided by 4.
Yes, sir.
Give you what?
3.
Plus 3 times 3. Give you
9.
9. And then when you add all of those, what you get?
18.
18. So that's the order in which you work these operations in order to get it correct. So oftentimes students forget how to carry out the order, and if you work it in a different way, you will get it wrong. Is that clear, guys? Any questions? Mr. Ojeno? Is it clear to you?
Yes, sir.
All right, Miss Cummins, what about you?
Yes, sir, it's clear.
And Miss Green?
Yes, sir.
Okay. Somebody's missing from class today. I think it is what, Miss Tulloch?
Yes, sir.
Okay. All right, so everybody, you need to remember BEDMAS for questions such as these. All right. Now moving along. Now this would be the last part of this slide. So I'm just going to see if I can switch slides a little bit. Let me stop sharing for a while. And going to jump on a new topic. And so I am going to do integer today. Now, I know I may have said to you that I'll be following the sequence of how the notes are ordered in the notes in the web on the website. But for a good reason, I decided to kind of go to integers, because generally I would go to fractions and then work my way down to integer. But I'm going to start off with integer first so that we can get the clarification of how to deal with integers out of the way, right? So before we start off on anything, first let me ask, what is integers? What are integers? What come to your mind, students? You should know the number system by now, so everybody should remember what integers are. What are
Positive and negative numbers, sir, including zero.
positive,
Or as you say, whole number.
negative
Yes, sir.
numbers, right? Including zeros. Now, if you follow what we're doing, we are now applying, we look at operation, we look at numbers. Now we're applying the operations to the numbers. And so one of this number, the set of numbers in the number system, integers, we are going to apply the operations to them. But when we are applying operation to integers, there are some rules that we have when we are adding, subtracting, multiplying, and dividing. And so we're going to be looking at those rules closely. But let us take a closer look at what integers are. Now, generally, I will give you the objective. So today we will define integers. We will add and subtract integers by using the rules of directed numbers, multiply and divide integers, which is a typo right here, by using the rules of directed numbers. Now, go ahead, Ms. Wilson.
Sir, I'm not sure if I'm the only person, but I'm not seeing your screen shared. It's just saying Sheldon James has started screen sharing, but I'm not seeing anything.
Let me see the hands of those who are not seeing my screen. All right, so I'm going to stop sharing and reshare the screen again, all right? Are you seeing it now, Miss Waysam?
No, sir, it is still doing the same thing. Let me try to log out then and then rejoin, sir.
Anybody else is seeing the screen? Raise your hand. Miss Green, you are seeing it? I'm not hearing you, Miss Green. Are you seeing the screen?
Yes, sir, I'm seeing you.
Miss Scott, are you seeing the screen? Hello, guys. Can you respond, or do I need to start? Miss Cummins, are you seeing the screen? It seems like
Yes, sir.
you're seeing it, Miss Cummins. Miss Scott, are you seeing it? All right. Are you seeing it now?
Yes, sir, I'm seeing it now.
All right. Is everyone seeing the screen? Let me see the hands of those who are not seeing the screen. All right, so I guess everybody is seeing it. I'm still trying to get some response from some persons who seem not to be responding. Mr. Ojeno, are you hearing me?
Yes, sir.
And Miss Scott, you hearing me?
Yes, sir.
Miss Scott, you hearing me? I'm not hearing Miss Scott. Miss Cummins, are you hearing me?
Yes, sir.
All right.
Yes, sir.
Now, if you're not hearing me, the best thing that you need to do is to try to log in back again. All right. All right. So I was saying to you that there are some rules of adding and subtracting integers. But remember that another name for integers, we call them directed numbers. And the reason why we call them directed numbers, can anybody tell us? Why do we call them directed numbers? Remember, there are positive and negative numbers. Why do we call them directed numbers? Anybody? Ms. Raysom? Why are they called directed numbers?
Because they can be looked at both ways, sir, whether positive or negative.
Because they can do what?
Be looked at both ways, positive or negative.
All right, not quite. One of the things that most of the time students kind of take for granted is the words that are used. Now, the words are generally literal when time we use them in mathematics. So if we say directed, we're thinking about direction, right? So they are called directed numbers because of the direction. They tend to have a direction on the number line. Now, one of the things we know about the number line is that we see that if we are going to the right of the number line, any movement to the right, you are increasing. So if you start at -2, then you go to -1, then you go to 0, 1, 2, you are increasing by 1. So any movement to the right on the number line is an increasing in numbers. And so we call that positive. Any movement to the left, you're decreasing. So we call that negative. So to the right is positive and to the left is negative. Now, the idea of positive and negative have been around for a very long time. Now, it has its use when we talk about temperature. There's a point that we call the freezing point, which water is frozen, and we call that 0. Now, if you get colder than 0, you would have probably the ice start swelling more. So it is getting colder. And so we would say that the number now get less than 0, because it means that if you're reducing the temperature and it is getting colder than 0, then the number must be reducing. So when it reduces past 0, we now assign a negative sign to say that you're getting less. So the -1 here means that you get less than 0 by 1, right? Now, one might want to argue, how can that be if 0 is nothing? How can we get something less than 0? Now, mathematics and the number system is a very complex thing. So the number system, we think about infinite movement in space. So if we are increasing, we can increase and increase and increase, and we get more and more and more by 1. And so if we go the opposite direction and we're decreasing and we're decreasing and we're decreasing and we reach 0 and we're still decreasing, that means we're getting less. Now, so the idea might come about that in terms of money, that if you have money, what you have is positive money. So if you're increasing more and more positive, that means you have more and more money. But if you find yourself going to the bank and you take out money, take out money, take out money, and if the bank allows you to take, you have $0 in there, and the bank allows you to take more money out of it by way of probably borrowing, then what is happening now is that that money that you take is no longer yours. It is someone else's money, because your money already depleted and finished, but the bank's still giving you money. So this becomes money that you owe. All right, so the negative numbers can be thought of money that you owe people, and the positive numbers can be thought of as money that you have for yourself. Now, if you think about it in this way, then you can see where this negative and positive can make some sense, right? And in a similar way, we deal with temperature like that. So now, because of the negative and positive numbers, there are some things that we have to understand before we add them. All right, so here we have a positive or a plus sign and a minus sign indicates a change in direction on the number line, right? So even though we might think of it as really getting less, one we are increasing and one we are decreasing, but really and truly, it means that the direction that you're moving in, if you have a positive, it means that you're going in the direction where you're increasing. If you have a negative, you're going in the direction where you're decreasing. So it is possible to decrease less than 0 based on these ideas, right? So as I mentioned with the bank, if you have $0 in the bank and now you start getting money that from the bank that is not yours, then now you're borrowing people's money. So it means that that money is a negative money for you, because you will have to pay it back when you get back your money, get back some money for yourself. All right, so a movement from a point on the number line in a direction towards the right is regarded as positive. A movement towards the left regarded as negative. On the number line, 0 is the point of reference, otherwise known as the starting point. So in order to go positive, you have to start at 0. And if you're to go negative, you're still going to start at 0. All right, so those are some things to note. All right, think about now when we are trying to calculate positive value. Because directed number have positive and negative value, in this section, we are going to deliberately attach some positive signs, which we call plus signs, to the numbers. Now, when we attach positive signs to the numbers, we can put the plus sign in front of the number like this one. We could keep the plus sign and the number in brackets like this. So it means that this is +3 and this would be +6. So whichever of these way you want to have them. Sometimes we don't attach the sign at all. And once you see a number without a sign, it is regarded as being positive. So when we're dealing with directed numbers, we can either put signs in front of the numbers to make them obvious what sign they are, or we can put no sign, which in that case, we treat the numbers as positives. All right, is that clear, guys? Any questions? Raise your hand if you're following me so far, if you're understanding what I'm saying. All right, good. So now, the trick now will comes in when we're adding, subtracting, and multiplying these numbers, right? So based on the signs here, we see that if we have a +6, and we're adding it, now this symbol in between them, we're going to think of this symbol as the operator, but these are just the sign to tell you whether or not these numbers are positive or negative. So we have a +6 plus a +3. And because these signs indicate direction that you move on the number line, it means that we can actually illustrate these things on the number line. So on a number line, I'm just going to see if I can construct a number line here. So let's say that this is our number line. Then if we have 0 in the middle, then going to the right, we have positive numbers. I'm going to move the 0 a little bit more to the left since we are not working with any negative.